The last type of problems, which is found in section 1.10, are problems involving distance, speed, and time. Those are relatively important in the sense that when we start calculus, we usually use those type of problems to motivate the creation of calculus or the need for calculus. And maybe it's a good thing to remind ourselves how speed, time, and distance are related to each other. So let's say you travel, I don't know, 100 kilometers per hour. That's your speed, right? And you travel at that speed for 4 hours. Okay, that's time, right? So that's time, 4 hours. I should write it here then. What would be the distance traveled? Well, that's easy, right? We're going to multiply those two together. That's going to be 400 kilometers. And by the way, notice how we multiply. As we multiply that speed and that time, the units sort of cancel out, right, to give us the units we have for distance. So that's important too. So what we see from this is that multiplying these two gives me distance. So essentially I've got distance is speed times time. And I could play with this equation. If I want to solve for s instead, s speed would be distance over time. If I want time, time is distance over speed. But mainly we're going to work with this one in this section. So distance is speed multiplied by time. So here's the first problem. We've got, this is the ground here. We've got two individuals. One is here. One is here. Maybe we'll call that one person number one. This is person number two. This person is walking at a speed of 6 kilometers per hour. That's pretty much the speed at which I walk. And this one a bit slower at 4 kilometers per hour. Okay. And between them, there is 8 kilometers. And I'd like to know when they will meet and how much time will they meet. So when will they meet? Okay, so here's how we're going to approach these problems. We're going to try to summarize the information we know for each person with respect to the three quantities: speed, times, and distance. And let's remind ourselves that distance is speed times time. Okay. So now I know the first person's speed. Yes, it's 6 kilometers per hour. Of course, it's important that everything is, all those quantities are using similar units. So your speed, if it's 6 here, the speed here must be using the same unit. So if we were working in kilometers per hour, right, everything has to be in kilometers per hour in that column. So 6 and 4 here. Time is, if I'm working at kilometers per hour, time has to be in hours here. This I don't know actually. This time I don't. Well, time is how long they will walk. That's exactly what I'd like to know. So I can see this is going to be my variable. I don't know how long they will walk, but once I know the value of t and the speed, I can recover the distance. Distance is the product of the two. Okay, so I can see here that by knowing what t is, I can fill in the information in my table. If that sounds complicated at first, like you can, like I said, try to fill in this information by assuming some values and see, oh, if I fix time, then I can fill in all the values in my table. So you see, if you say time is 2 hours, then that means that the distance traveled is 12 here, and this is 8. Clearly, if that person walks 12 kilometers and the other 8 kilometers, they actually they will have crossed each other at some point. So time is probably not 2 hours, right? It's too much. If I shrinking down to a half an hour, does that work? Half an hour would mean the first person's going to walk 3 kilometers and the other 2 kilometers. In that situation, they haven't met yet. They're closer to each other, right, to one another. In fact, they've traveled together 5 kilometers, so there's still 3 kilometers between them. So so the answer is, we can see it's between somehow 2.5. But let's try to get this from using a systematic way. But the idea is that we see that by fixing t, we can fix all the other values. And that's exactly what happened here. We fixed t and all the other values, 6t, 4t, were obtained from it. And what do I want? I want the total distance. So maybe I should specify what t is. So let t be the amount of time that they walk. Then I know that the total distance traveled must be 8. So that means that 10t must be 8. That means t must be 8 over 10. And t is in what? It's in hours, right? And that's in kilometers. So this is 8/10 of an hour. Okay, what's 8/10 of an hour? Well, actually, that could be my answer. I mean, maybe it would be nice to have it in minutes. It's 8/10 of 60 minutes, right? So how many minutes is that? Well, that's going to be 8 times 60 over 10 simplifies to 6, right? It's 8 times 6 minutes, so that's 48 minutes. So you see, we knew it was between half an hour, 30 minutes, and 2 hours, 120 minutes. So the answer is actually 48 minutes. Let's take a look at another one. Now we've got 2 persons that are actually initially at the exact same place. Okay, one is going to move in this direction, the other in this direction. What we know is that this person here walks 2 kilometers per hour faster, but we don't know at which speed they each walk. However, we're told that after 3 hours, they are 30 kilometers apart. And I'd like to know how fast did each walk. So maybe this is person 1, this is person 2. Okay? So person 1, person 2. And then we're going to try to fill in the values for speed, time, and distance. And if you like to work with numbers at first, do that. Okay, see person 1, maybe person 1 walks at, I don't know, 6 kilometers per hour. That would mean person 2 walks 2 kilometers per hour less, so that would be 4. If they walk 3 hours, we know t is going to be 3, right? They walk 3 hours. Person 1 will cover a distance of 18 kilometers, and person 2, 12 kilometers. And hey, we're kind of lucky here, because it adds up to 30. Okay, I got that I didn't know the answer, honestly. Okay, so let's try to modify this slightly, because now we know the answer. Let's say it's not 30 kilometers apart. Let's say they are 50 kilometers apart. Okay, so that wouldn't work, right? It'd be that means the individuals are too slow. It wouldn't be 50 now. So we know it's going to be a bit more than 6 and 4 in that situation. So let's try to do this. But my point is, once I know the first person's speed, I know automatically all these quantities very easily. So let's do that. So P1, P2. So suppose that person 1 walks at a speed s that I don't know. That person 2 will walk at a speed s minus 2 time is 3 hours, and distance is just a product. So 3s and 3s minus 2. Don't forget your brackets. And I know that this needs to add, so it adds to 50. So let's try to solve this. So we're going to say let s be the first person's speed. Then we need 3s plus 3 times s minus 2 to be equal to 50. So that's 3s plus 3s minus 6 is 50. So that's 6x minus 6 is 50. So 6s is 44. So s is 44 over 6, which is what, 22 over 3 kilometers per hour. Okay, and so that would mean the first person, and this is not something I would have found by trial and error, by the way. The first person walks, maybe actually runs almost, at 22 over 3 kilometers per hour, and the second at, well, we need to subtract 2 from this. So 2 is 6 over 3. So 22 minus 6, that's 16 over 3 kilometers per hour. So 22 over 3, by the way, is a bit higher than 6, right? It's 6 would be 18. So it makes sense, right? Because I was expecting something higher than 6 and 4. So we have something, in fact, higher than 6 and 4. And we could verify this, that this works actually. So in 3 hours, you see they have walked 3 times 22 thirds plus 3 times 16 thirds. I'm getting worried now. 3 over 3 cancels out. So 22 plus 16 is 38. Aha, so what mistake have I done? Let's take a look and correct it. Because this should be equal to 50 and it's not. Okay, could you see my mistake? It's right there. I did. So it's right here. I had to add 6 on both sides and I subtracted 6. So let's backtrack. We've got 56. So this is going to be instead 56 over 6. So 28 thirds. So this is going to be 28. And from 28 I subtract 3, so 22. And now 28 plus 22 is 50. Yes, so it's going to work out. So it's always good, you see, to check your answer, because you never know when you're going to make a small mistake like I did. Okay. So for the last problem, I'm going to let you do it on your own, okay? And you can try to compare your answer to mine afterwards. Okay, so here's the problem. You've got, I don't know, a little house here, and you've got a first person leaving the house at a speed of 4 kilometers per hour. Okay, 6 hours later, that person has moved, right? There's a second person that leaves the house at a speed of 8 kilometers per hour. And all that occurs 6 hours later. So clearly this person right now is at a distance of 24 kilometers, right? From the house, because it has traveled 6 times 4, 24 kilometers. Okay, and it keeps walking, and we want to know how long before the second person catches up the first one. Okay, so try to fill in the information that we have in a little table. If it helps, Uh, so this is person 1, right? This is person 2. And if it helps, you can work with actual numbers and see how far how wrong you are with the values you've decided to choose, but mostly see what quantity needs to be fixed in order to fill in the values for all the little boxes in this table. So you've got speed, time, and distance. Okay, try to figure out also which equation to solve and solve it, and compare your answer with mine. So this is what I have. I have fixed the amount of time walked by the second person, since that basically corresponds to the amount of time before that person catches up the other one. It's the amount of time that the second person has walked. If you fix this, if you decide that t is fixed here, just notice that the amount of time needed will be the value of t you found minus 6. Okay. So if you actually set t to be the amount of time walked by the second person, automatically the value of t is the answer to the problem. So if person 2 walks for t hours, the person 1 will walk for t plus 6 hours. And we get the distance by multiplying t by s each time. And what we want is we want these two to be equal. So I need to make them equal in order to recover the value of t. As I do this, I get t equals 6. And this is my answer. The second person will catch up the first person in 6 hours. And I can check that my answer is correct by replacing t by 6, and I can see that the distance traveled by each person will be 48 kilometers after when they meet. So those two quantities are equal, and therefore my solution is correct.